Hello, welcome. We are going to fill out this rational functions cheat sheet today. This is going to be really helpful for, this is going to be really helpful for just like kind of going through the 6-step process that we talked about in section 2.7. There's a lot of stuff to remember here, and so being able to kind of use this sheet to help guide you along the way is going to be really helpful. So basically we're going to talk about how do you find the whole, how do you find the vertical asymptote, how do you find the x-intercepts or the zeros, how do you find the horizontal asymptotes, slant asymptotes, and so on and so forth. The first thing I want to point out though is this first line on this, which is the factor the numerator and the denominator first if possible. So that's always, if we can factor, we want to factor first, okay? And then I want to make another quick point that if it asks you for the domain of your rational function is going to be x is in the set of all real numbers, but x cannot be any value that makes the denominator 0. The denominator 0, right? So that's always going to be your domain. So if it's asking you what is the domain of the function, then the domain is just x is in the set of all real numbers as long as x is not equal to any value that makes the denominator 0. I just thought, there we go. Okay. So let's talk about, excuse me, a hole, okay? So a hole is literally just a break in the graph, like the graph is continuous and it skips over a point and then it keeps going. So when we have the hole, it's when I have a 0 of the numerator and the denominator. So it's something that's both on the top and the bottom, okay? And that is the x value of the hole. And then to find the y value, you take that x value and you plug it back into the function, making sure that you cancel out the factors that created the hole in the first place. So if we look at this example, just say I have x squared plus 3x minus 10 over x squared plus x minus 20. Okay, so I'm just going to factor this real quick. It should be pretty fast. X plus 5, x minus 2 on the top. Again, if you don't know how to factor, this unit has probably been incredibly difficult. Okay, you have to know how to factor. What am I doing? Oh, minus 4. There we go. Okay, I factored it. Since I have x plus 5 over x plus 5, I have negative 5 as a 0 of the top, and I have negative 5 as a 0 of the bottom. So that tells me that there's a hole. And the hole is going to be at negative 5, comma something. We don't know what that something is. Okay? So what we're going to do is we're going to plug negative 5 into what is left of the function. Sorry, my handwriting is getting a little bit out of control as my pen starts getting jumpy here. Okay, so here I have x plus 5, x plus 5. So I'm just going to cancel, ignore that, and what's left is x minus 2 over x minus 4. So I'm going to plug negative 5 into that. So negative 5 minus 2 negative 5 minus 4. And I get negative 7 over negative 9. The negatives can cancel, and I get 7 over 9. So the whole here occurs at the point negative 5 comma 7/9. Okay, so if you have something that is a 0 on both the top and the bottom, then you have a hole. And then to find the coordinate of the hole, you have to plug in the x value into whatever's left of the function. Hopefully that makes sense. We're feeling good. Let's try the next one. Vertical asymptotes, values of x that are zeros of the denominator only. So here we're looking at, is it a 0 on the bottom only? Okay, so if I use this same equation, and I'm going to go ahead and just write the factored form since we already did the work of factoring, x minus 2, and then x plus 5, x minus 4. So negative 5 is a 0 of the bottom, but it's also a 0 of the top. That's how we got the whole. So that is not a vertical asymptote. 4 is also a 0 of the bottom, and that is not a 0 of the top. So this right here is my vertical, is the information I need for my vertical asymptote. So this just tells me that x equals 4 is the equation of my vertical asymptote. So it's just going to be a vertical line at 4. Hopefully we feel good there. Let's move on. Okay. Next one is x-intercepts, or the zeros. So these are the values of x that are zeros of the numerator only, so the top only. So again, if I take that same, excuse me, holy cow. I take that same equation, x plus 5, right, x minus 2 over x plus 5, x minus 4. Okay, so here x plus 5 is a whole, so even though negative 5 is a 0 of the top, because it's also a 0 of the bottom, that's the whole. Here, I have a 0 of 2, and that is not a 0 of the bottom. So that tells me that I have an x-intercept at 2, 0. Okay, 2, 0 is my x-intercept. Just to show you kind of examples here. Actually, I'm not going to do that. Hopefully that makes sense. Something that's 0 of the top only. Okay, moving on. Horizontal asymptotes, we have 3 options. If the equation is bottom heavy, it's going to be y equals 0. If the equation is balanced, then you take the coefficients of the top and the bottom, and you make it a fraction. And then if it's top heavy, it's none. So what I mean here is if I have like y is equal to ax squared over bx squared, because this is balanced, I'm going to take the leading coefficients, and the equation is just going to be y is equal to a over b. Okay, so I'm going to do three examples here, so I'll try to write small. The first one is y equals 5 over x minus 3. So in this case, on the top, I have x to the 0, and on the bottom, I have x to the 1. So in this case, this is bottom heavy because the degree of the bottom is bigger than the degree of the top. Since it's bottom heavy, the equation for the horizontal asymptote is y equals 0. Let's look at another example. Y equals 5x over x minus 3. In this case, on the top, I have x to the first, and on the bottom, I have x to the first, so this is balanced. Since it's balanced, I'm going to take the coefficients of the highest degree. So on the top, it's a 5, and on the bottom, it's a 1, right? Because there's a 1 in front of that x. So I get 5 over 1. So the equation of my horizontal asymptote in this case is just y equals 5. And then the last one, let's do y equals 5x squared over x minus 3. On the top I have x squared, on the bottom I have x, so this is top heavy because the degree of the top is higher than the degree of the bottom. And so since it's top heavy, there is no horizontal asymptote. So hopefully we feel good on that. Again, reach out, make sure you're understanding what's going on. 2 more to fill out and then we're done. Slant asymptotes here. If you have a slant asymptote, first of all, your graph has to be top heavy. But not only does it have to be top heavy, it has to be top heavy in the sense that the top exponent has to be 1 more than the bottom exponent. So it can't just be any type of top heavy, right? The exponent on top has to be 1 more than the exponent on bottom. Or the degree, I guess I should say, right? So for example, if I have y is equal to x squared minus 2x plus 5 all over x minus 3. Okay, I'm going to take the 0 of the bottom, which is 3. We're going to use synthetic division and divide it by the top. Here's the top. So quick synthetic division, the 1 comes down. I multiply and then add, and then multiply and then add. And whatever I get for the remainder, I'm just going to throw away. I'm not going to look at. So then I can write the equation y equals, here my coefficient is 1, so 1x, or just x, plus 1. So the equation of my slant asymptote is the line 1x plus 1, which I know how to graph, right? I start at 1, and then I go up 1 over 1. So hopefully that makes sense. If your top exponent is 1 more than your bottom exponent, you have a slant asymptote, and you're just going to use synthetic division, throw away the remainder, and that's the equation of your slant asymptote. The last one that we're going to do is the y-intercept. For the y-intercept, it's nice and easy. All we're going to do is plug in 0 for x. Right, plug in 0 for x. So if we go back to that original function, x squared plus 3x minus 10 over x squared plus x minus 20. I can plug in 0 here, or I can factor it first. Here's the factored form that we found. So I can plug in 0 on the original, or I can plug in 0 in the factored form. Sorry, totally I'm spacing out. It doesn't matter. I'm going to get the same thing no matter what, okay? I usually like this one because when I plug in 0, I know that this is 0, right? Because 0 squared is 0, and I know that this is 0. So I really get like 0 plus 0 minus 10 over 0 plus 0 minus 20. So really I can just like cancel out all those zeros. And I just get negative 10 over negative 20, which ends up being positive 1/2. So this graph crosses the y-axis at 0, 1/2. That tells me my y-intercept. So that's it. That's like all the different pieces that we looked at in 2.6 and 2.7. Hopefully this is just a nice little sheet for you to go back and look at, like if you're trying to find the slant asymptote. How do I do that? And then you can come to this sheet and look at it. If you're struggling with 2.6 or 2.7 or have any questions, just make sure that you reach out. Let me know. Otherwise, that's it. Enjoy the rest of your day, and I'll see you soon.